Alright, so we're going to have to play a little bit of catch up on the lab because of the gum part of it. So over here, you're going to wrap this up. This is pretty easy. You should have selected, again, 10 random squares. Okay, so we all used A6, but these should all be different numbers from your group members. So you will not have the same answer. Down over here, you total up how many were in each square. And then this is the sum of all of them together. This is the average number, okay, the average number in each of the squares. So you have a total of 10 squares, so take A divided by 10, and that gives you your average number of sunflowers per square. Now, what's the estimated average in the 100 squares? Well, so because you have 100 squares here. Take B, so this right here, so whatever this number is, and multiply it by 100, and that will be your estimated average, how many sunflowers are in here. Now take C and put it over here as your estimated total. Now you need to count the sunflowers by hand. So go and find out how many sunflowers are in the grids. Right here, all I need you to tell me was your estimated number higher or lower than the actual, and by how many. So say it was higher by 30 sunflowers or lower by 20 sunflowers, whatever it happens to be. But again, different people, like I said, selected totally random squares. No two people are going to end up with the same exact answer. It'll be really obvious that you copied off of somebody because there's no way you're going to end up with the same exact answer. The only thing that could be the same is the total number of sunflowers because everybody's going to have the same number for that. Down over here, mark and recapture. Click on this simulation, and it's going to take you here. You might need to accept Adobe Flash. So before we get to the simulation, I just wanted to cover this. We covered it in class, and I know I went super fast, but I'm going to have this here so you can write it into your notebook if I went too fast for you. So there's a couple variables here. Big N is still the population estimate. Right over here, if you didn't do it in your notebook, put big M, because you might confuse, uppercase M with lowercase m. Put time passes. I'll explain that in a second. Put little n, so put little n and the number of organisms in second capture, and then put little m, number from n, this one, with a tag, and I'll explain all this in a second. In mark and recapture, you go out and you capture a certain number of organisms and you tag them. As far as how many organisms do you tag? This one is kind of a guess. You have to guesstimate what the population size is. So I always use ants because they're a really good example because there's a lot of them. If you go out to an ant hill, you kind of have to have an idea, okay, well, how many ants are in here? Obviously, there's going to be more than 5. So it's just a guess. How many do you think there are? 500? 1,000? Once you have your guess, you want to get about 5 to 10% of that. Okay, so the easiest number is 10%. So if you think there's 1,000, you might want to capture 100 of them. Okay, so you capture them, you tag them, you put some sort of mark on them, and the mark could be a pit tag, it could be a sticker, so long as it's not going to fall off. It could be some sort of tracker. Again, something unique that you can identify again. You tag these organisms, and then you let that 5 or 10% go back into the population and mix with the population. This is where the time passes thing. So you wait for a few days. You go out and you capture more organisms. Do you have to capture 10% again? No. If you capture more, you capture less. Doesn't really matter. It should be close to about 10% again, or what you think is 10%. Now, once you go out and you capture this number, you have to see, okay, well, how many of them have the original tag that I put? And that will be your little m number. Then you just put it into this equation. Big M. How many did I originally capture and tag? Times little n. How many did I capture the second time? Divided by how many of little n were marked. And this is what you're going to do in the simulation. So in the simulation, you're going to mark butterflies. So right here I have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. So you're going to mark them. This will be your big M. Now normally you want to run multiple trials. So you're going to go out and you're going to recapture multiple times. but the number you originally marked is going to stay the same. So here we're capturing and we're marking 40 of them. Okay, so that means throughout all four trials here, that number is not going to change. It's always going to be 40. That's how many you marked. That's how many you're going to release. So we're going to release the butterflies. There they go. Now you're going to let a couple of days pass. Obviously, this is a simulation, so you don't need a couple of days to pass. Now, when you capture butterflies, again, it's going to give you a different number each time. This is like, you can tell if people are copying because there's no way this random simulation is going to give 4 of the same exact trials. Okay, so don't copy off of somebody, or don't let somebody copy off of you, because I'm going to tell if you have the same exact numbers. So, little n, how many did I capture the second time? Well, 1, 2, 3, 4, 5. 1, 2, 3, 4. That means that I went out and I captured 20 of them. Now, how many of those 20 were marked? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of them were marked. Now, I plug it back into my equation. So I'm coming back here, plugging this back into my equation. 40 times how many did I capture the second time? That was 20. So 40 times 20 divided by how many were marked? That's 9. And that will be my estimated population size. So again, if I'm coming back here, I would enter that number right here. Now, if you're unsure if you're right or wrong, then just click on this one that says estimated population size. So here you go. It should equal 88. Okay. They have it out of order here, though. So they have it marked, so number in second sample by marked in first sample. So they have it reversed from my equation. It still works out the same way. All right, but use my equation, though. Okay, use my equation. This will matter later on when I start playing around with variables. So then you just recapture and you set. And then you run the same thing. How many did you originally capture? 40. How many are in this sample? Well, 20. How many of them are marked? 4, 5, 6, 7, 8. In this case, it's 8. Please don't use my numbers. Like I said, you will generate different numbers. And then calculate for the population size. Again, if you're unsure, click here and you should get 100. So like right here, you would enter in 100. Now, yes, you can just keep clicking. Like you could do it again and just estimate the population size, and it will give you a number, and you can just put it here. But get the practice. Like I said, get the practice in. Finally, right here, this is where I'm going to need you to show your work. Same thing. You capture 20 tuna. You mark them. You let a few days pass. You recapture 50 of them or 15 of them. If 10 of them were marked, what's the population size? Let's just say you go out, you do another count. This time, 1 of them are marked. Okay, what's the population size? Over here, you capture 20 sharks. A few days pass. You recapture 50. 4 of them are marked. What's the population size? 10 of them are marked. What's the population size? Again, make sure you show your work. And just keep using this equation that I have right here. All right, and that should walk you through the back part of the lab.